Hello, everyone. My name is Hugo Dorado. I'm a researcher from the Biodiversity Sea Alliance, and today we're going to talk about the dataset structure and cleaning process. This material is part of the analysis of information and data mining, uh, made in coordination with Biodiversity Sea at Illinois University, CIMMYT, and CCAPS. During this presentation, we're going to see some of the most frequent mistakes in the data sets, and from this moment on, we'll be able to identify some of the inconsistencies and how to deal with them. The first thing that we have to guarantee is the structure of the data set that we are creating. The idea is to have all the observational units that we've defined in each one of the rows and columns. And one of those associated variables should be associated to one of those observational units. This is one of the examples that I have from our databases, where each one of the rows would be a harvest cycle for rice. And in the columns, we have the date when it was sowed, the harvest date, the variety, and the yield. It's important to always, every time that we create a database, we should establish or create an identification, an ID column that will help us to give follow-up to each one of the registries while we process more information. This is important because when we need to go back to a certain point to assess some failure with the registry, or if we need to link this database to another database, this identification will allow us to have the traceability of the whole process that we can have and go back to the beginning to find if it was a processing a mistake or something that was from the beginning. So from this moment on, we can never forget to take into account that we have to revise and guarantee that the ID is within our database. Another important key factor that we have to take into account whenever we create a database is the creation of the Codebook. This can be done through very simple procedures where we can begin by identifying short names by each one of the variables that our database has. That is, for this short name not to have more than 15 characters. And also, if we're going to have several words, we should not use spaces or commas or periods to divide the two words. Instead of that, we can use underscores or uppercases. It's also important to highlight the complete name of each variable associated to that short name, and also to establish the measurement unit that we hope that it's already uniform for the whole variable. It's also important to take into account the range of the variable between the minimum and maximum variable for numerical variables and also dates, and qualitative variables. We should show all possible categories that could be involved and expressed there. This will allow us to facilitate the comprehension for our database whenever someone else wants to use that information, either for the same task that you're doing or for other tasks. One of the most frequent problems would be the format in each of the variables. This is one of the most common mistakes. It has to do with the dates. The dates have many problems. One of them is the fact that the different versions of operational systems like Windows or other computers have a different language configuration. So there could be a different format for dates, especially in regards to the order in which you input the date and the month and the year. So we should revise each one of the dates in order to guarantee that there are no differences or mistakes. If we choose a format, all of those columns should be uniform. For example, the English format uses month, day, and year, but in Spanish it's the other way around. Well, not the other way around, but it would be the day, the month, and the year. So this could create conflicts whenever we want to upload that information in a specific software when we want to use to do an analysis. It's also important to revise the geographical coordinates This is one of the most important variables that are registered for this type of analysis. And there are several problems that could arise, especially when they are manually inputted. This happens because the coordinates could be registered in different units of measurement. Some of them would be degrees, minutes, and seconds, or degrees, decimals. This could also generate conflicts when the registry is being done. And it's also important to uh, do an assessment of this in order to evaluate the quality of the registry. There's support software that helps us to do that revision of the geographical coordinates and to evaluate them in a map. One of them would be Google Earth, Google Earth, or Quantum GIS that we're going to show in the course, and the other one would be ArcGIS. The idea is to try and identify that the coordinates are on a specific lot, if you can see the image, and they should be close to the location where you expect it to be. And also try and avoid this, to have these types of mistakes. When there's a problem with the coordinate registry, this is what usually happens. It falls on the pin falls in another location, another country, or even in the sea. So this way we can identify different problems where you can identify the format and do the corresponding um, arrangement in order to properly identify the coordinates. Also, date confirmation that's in the database can be done based on the road calculation between the places. The date of harvest and the date of germination, we wouldn't expect to have more than 150 days, which is the maximum um, number. In this regards, we can identify there can be some problems. There can be duration cycles that are too short, which makes us think that there's a problem with the date, and other cycles that are too long, where the same thing happens. It's always very important to properly calibrate these things like dates and coordinates, because this is what allows us to link the climate information and also the soil information to our database. If we do not have a proper processing of these variables, coordinates, and also dates, we won't be able to have a good quality in the information of the climate and soil information. Another frequent error in the databases, and I mentioned this in the other presentation, is related to the systems of units. This happens when we do not use software to capture data. This is one of the cases, the first projects where I participated, where some producers registered their production in boxes per week. Others registered in kilograms, others in cartons or boxes. So this would be a big challenge because we would have to identify each one of those producers and ask them how much each box weighted in order to do the conversion to kilograms. So this has also to be done in order to standardize the different variables and the measurement unit before continuing with the analysis. The same thing happens with the area. There could be different ways to register each one of the values in terms of area. So it could be hectares, and there could be another register that says that the cultivation is dispersed, or it can even be recorded as a bushel. So it's indispensable to understand the measurement unit that we're going to use in order to analyze our data. Coordinates can have a bad record or registry in the different combination of formats that exist. This is another example where some added these degrees to the north or others, and others had problems with the decimal points. Instead of using a period, they used a comma. So that's another one of the most typical mistakes that we make in the databases. So we have to identify that the system that was used to separate decimal points and thousands is the one that is read by the database in the end. Sometimes they can add additional information and it can finally end up hurting the database. So all of those errors should be taken into account when processing data. Another common mistake when we identify qualitative, qualitative information would be the characters, the combination of upper and lower case. You can also use a software to record the data where everything's properly standardized. But in the case when you have an open possibility, we're going to see these type of restrictions. Sometimes in the registries you change columns. For example, here when we expect a date, there's a different variety or a variety, and we can also have combinations of varieties. So we have to take decisions to decide if we're going to create another category that's called combine, or we're going to remove these productive cycles where there were mixed varieties. In R, we can process the information, and we're going to carry out an exercise afterwards to see what exercises we could have in order to process this database before continuing with the analysis. Another important aspect to assess every time when we analyze data is to identify those outliers. This could be due to bad records or registries or mistaken information, or simply because it is special data that is out of the trend. But usually these are real values, and the only way to identify them is, first of all, to properly explore the database. We can look for the minimum and the maximums. We could do this from R, but an easy way to do this is by using the box plots. And these box plots allows us to see those outliers in our database. We not always have to remove them. So we have to use our criteria to decide what to do and to assess if this information that we should keep or not. And nevertheless, there are clear mistakes in the database. And if we keep them, they're going to affect the results that we can generate during our analysis. So it could be better to remove some of them or mark them as lost values so that we can estimate it afterwards. With this, we could establish some criterions that would allow us to structure and clean the database. The first thing that we have to guarantee is that in our information matrix, each row represents an observation unit or an analysis unit, and each column represents a variable in our database. And we also know that it's important to create a code book that will allow the new researchers to compile information and perform other analysis. It's also important to verify that all the records of the variables should have the same system of units, since this could also interfere with the quality of the results that we could generate. We should also detect and solve all the problems related to formats or measurement units with the coordinates and the dates, because the information that we have depends on the silt and soil information that we have in our database. We should also solve the case problems, because we wouldn't have to have two categories that are the same, would be included in different classes. So it's always important to try and solve these case problems and standardize each one of the variables, the qualitative variables. It's also important to identify outliers and establish a decision that we're going to take based on those outliers, if they're going to be removed, if those rows are going to be removed, or if they're going to be included as missing data to process it afterwards. Well, having said this, we finished this section. I hope that it was useful and that you liked it, and continue advancing in this course for Foundations of Analysis of Information for Agriculture.